presentation. Our next speaker is Colonel Gil Maus. He is a veteran of the Israeli Defense Forces. He is Senior Director, C4I SR, Elbit Systems, Land and C4I Limited. He completed his military service with IDF in 2011. He is a graduate of National Security Studies. He is a BSc in Electrical Engineering, Master in Political Science and National Security. He specializes in management of large-scale technical projects. He is expert in C4ISR, land warfare, system design, and implementation. He is going to speak to us on BMS, the edge of counterterrorism. Over to you.
Distinguished generals, ladies and gentlemen, I'd like first of all to thank FICI and SP Publications for facilitating this opportunity to share with you some of the experience we have learned. My presentation will address, as titled, what I think is to be a global issue. Just to point out where we are, in mid-2013, the IDF had reached, with the Elbit systems, a full digital army from head to toe. This allowed the operation in 2014, this last summer, to be fully conducted with Elbit's BMS systems all the way down. And in my presentation, I will try to demonstrate the abilities, lessons learned, and way forward that we see using the BMS systems, which are, although I have said they're on their full operational capacity, we are still growing them and keeping them on the edge of technology. I must state that we did have a previous operation in 2009. In 2009, only some of the systems were issued, not all of them, and we mainly had systems within our HQs. This enabled us to have some lessons learned and to understand how important is that you have an agile system which is flexible enough and you can modify it to the relevant arena, to the relevant threat. I must state that this system, our digital system, was designed primarily for regular warfare against regular armies. I can probably open a long speech here about how the next war is going to look like, but I think it's common knowledge that wars globally have been changing, and you see much more of a terror threat being what's in front of us. So just at a glance, looking at terrorism of our time, and I would like probably to go through a few highlights that will make a better understanding of why the BMS is giving us that advantage. The enemy is on a small scale. It's the enemy size. It's its signature on the battlefield. It's the terrain you fight in, which is complex and small. The weapons, even them, are quite small and not as large. If you used to work with very large radars in the past, now you need very small radars because it's just behind the corner in the street next to you, and you would like to find a metal object of this size and not a brigade of tanks going around in the terrain. Target lifetime is extremely short, and we are unfortunately fighting in the arena where population and uninvolved are within the fighting arena. RMA was mentioned earlier this morning, and I think one thing one must say about RMA is that the technology it relies on, what was thought to be introduced for higher lethality, we find out that today we mainly use it in order to distinguish the targets and distinguish between the uninvolved population and our actual targets, and this is the major contribution of the RMA in such an arena. This is a real Intel detailed air photo. I just took the liberty of translating it, of course, into English, so all of the terms would be understood. And I put it there just to illustrate both the arena and the challenge. Concerning the arena, one can note the density and mix-up between civil infrastructure and military targets. Regarding the challenge, one can see that we are currently using here multispectral Intel sources, which will not go into their nature. We do see that since the terrain is very complex and very dense, there's a high risk of friendly fire, and coordination is relevant at all levels, and especially combined arms coordination is relevant here. Just imagine if you're standing right in the middle of this area, and you would like to coordinate some airstrike or a naval vessel that will assist you with fire. This is something that, if time allows me later on, I will show you how we can actually bring this picture up alive, not only for some officers in a rear HQ, but for the soldier on the ground, for the commander on the ground, for the combatant, wherever he's walking or in a tank, and he would like to see this exact picture, but something that he can make sense out of. What did we actually see on the field? The ODA loop was mentioned before. Not only the sensor to shooter, which is quite known, but also sensor to maneuver, how you reach the right place, the right target on the right time. We saw terrain dominance through an array of sensors. We used radars, cameras, day, night, other Intel sensors that were available, including other agencies which are not military. Since we have connected to all of them, we have received all of that amount of data, again forming a much better fused picture down to the soldiers. And of course, if we look at the video, and I'll show you a couple of examples, we saw live video feed going down to commanders at very low levels. We saw use of live video on the tactical level from our Skylarks, the mini UAVs flying over the forces, which actually deliver the information directly to the company commanders and the battalion commanders. And of course, looking at the classical BMS feature of situational awareness, time-relevant intelligence, and it's all written out there on the slide, so I won't go into it. We did see the close coordination and things which I cannot show and prove here, but we have reduced significantly friendly fire issues since coordination between forces has become much more simple and much more understood by the soldier level. I would like to share with you a few operational examples. Again, I'll show you in this case, and I'm sorry that this thing is not translated into English, but what you see here in this case is a border protection system. It's an array of sensors. We see here just the camera point of view, but radars and other sensors are involved in this interception. The live video feed that you see goes to the command posts. The targets are marked on the C4I terminals, distributed instantly to tanks, artillery, and naval vessels, and resulting in quick response and closure of this event. I'll give you here another example, in this case of a sensor to shooter loop. You do see those black spots. This is a thermal imaging taken from the ground, and again you see that in this case the sensors picked up those targets. Again, video feed was run all over, command post, C4I terminals, quick decision making, and coordination of fire. One can actually see that live video feed as it happens, and as you can see, targets have a very short lifetime, literally. We saw that accurate maneuver was being assisted by the system. And again, in the arena that I've described before, once you have an arena of IEDs, anti-tank missiles, suicide bombers running out on the field, you want to be very accurately to the right spot at the right time, go in and out, and not become a target yourself. Again, this assisted quite a lot. I would like now to give another few words about GIS and perhaps even show a little some of our newer technology. What we did see is that terrain changes. Once you go into such a complex terrain, things are being moved, structures are falling and blocking streets. You want to assist your forces with relevant GIS material. You want to give them the newest digital map. You want to give them a map that is not older than 24 hours. You want it to be very relevant for them. If there are any changes in the terrain, you would like to mark them on the maps. You would like it to be distributed, and this is something that can be done. But again, understanding such a picture is quite difficult. That's why I will use the following minute just to give you an explanation. Again, a complex terrain. I picked it up in some 3D so you can understand what's happening. Quite a lot of enemy, quite a lot of our forces all mixed up. And this is a current terrain. But a combatant usually sees it through his sights and through his eyes. And this is how he's going to see the terrain. So basically, what we would like to do is throw all of the terrain onto the sights. So we take that two-dimensional picture that I've shown you before, and we would like to place them, as you can see on the lower part of the slide. We would like to demonstrate them on the scope. But bear in mind that if you use telemetry, you'll probably end up by showing this picture, which is not very helpful for any combatant on the field. Well, our technology allows us to give such a picture. And again, this is something that I've chosen to show you, and if I'll have some more time, I will elaborate more. Some lessons learned. First of all, that we have seen that it was a very efficient force multiplier. We saw that going down with terminals down to the lowest levels is quite beneficial. Things at the end of the day result up at a very low level, at the section level, at the soldier level. This brings out the right outcome. This gives us the right use of time. The highest resolution is needed, both by live video and GIS, as I've explained. Terrain changes, and you want to communicate it to your forces. And of course, you would like also to have all the relevant communication to all of the relevant intel agencies. Looking at the way forward, where we're going, soldier solution, this is 3 things I have to say about it and stated here more and more. And we see them not only being distributed to more users, but we do see technology advancing. We do see our next generations of the soldier solutions to be very fit for the soldier, very easy to use. A combatant on the field is not a computer operator. He's a weapon operator. He has to fight, and we have to help him do that fighting. We look at connectivity as a major issue, how we connect not only within our own unit, but with adjacent unit, with higher echelons, with other services. This is something that is extremely beneficial. And as I've mentioned before, and I think it was mentioned here earlier too, the very thin line between defense and security, I think is wiping out. I don't see that line existing anymore. And therefore, we do see a lot of intelligence going between security agencies and defense forces. Perhaps just another small example of terrain solution, and I think it will be appreciated by anyone who does GIS. But basically, if you reach terrain, and you want a new picture of it. What we do now, we send a small mini UAV or Skylark up in the air. It takes a picture, and I'll show you what we can do on an operational level, if it works. Well, basically, we take the Skylark, move it around the terrain, and take the pictures, and then by the algorithm, what we do is we start formulating a model of the picture. The model is even being registered, so it's built up, and you know exactly which point is where, and resulting in, and it will look quite, if it runs, of course. And as you see, this is already a completely synthetic picture of the arena. It's a 3D model. It had been built on the go, on the field. This is a tool we're aiming for very low levels. It's something that is run on the field. It's not being done by any laboratory in the back. It's being done on the field using the mini UAV of the battalion or of the company, and right in near real time already serving the forces on the ground. So basically, this covers my presentation, and I would like to thank you.
Thank you, Colonel Maus, for a very interesting presentation. Our next speaker is Colonel Richard Sundaram. He is GM Defense, NIIT GIS Limited. He is a master's in engineering from IIT Kharagpur. In his 25 years with the Indian Army, he was involved in a joint Army DRDO project for development of an indigenous electronic warfare system, which has been inducted into service. He has designed and developed GIS software for electronic warfare, intelligence, collation and analysis, which is being successfully exploited for tracking terrorist activities in J&K. Now, as head of the defense vertical at ISRI India, NIIT GIS, his focus is on innovative use and exploitation of ISRI GIS, technical defense, internal security, and for the intelligence community. He's going to speak to us on tactical lightweight GIS.
At the outset, I'd like to thank FICCI for giving us this opportunity. I'll be speaking to you on tactical lightweight GIS, or geographic information system. Normally this word, the terms tactical and lightweight, refers to hardware systems, especially in terms of SWAP, or what we call as size, weight, and power. But GIS is essentially about software, and software has no weight. So where exactly does all this thing fit in? That is what I'll be covering in the next 15 minutes or so. I'll start with giving you an evolution of GIS technology, just few slides, telling you how the technology is being focused, especially how the trend is going as far as GIS is concerned. So GIS is all about computational power of the chip, because any niche technology requires that computational power. And as the computational power keeps increasing or getting enhanced, so the GIS becomes better and better. So what are we talking as far as the lightweight GIS is concerned will come in. Next is the need for the lightweight GIS. This is something which we need to understand. If technology is so good and the computational power is increasing day by day, why do we require a lightweight GIS in the first place? So I'll talk about that, especially in the context of the Indian defense. Then when we design a lightweight GIS, then what are some of the challenges that you are going to face? That will be the next thing, and followed by the ESRI's answer as far as a lightweight GIS is concerned. What is the solution that we have developed upfront? And finally, we'll see some small demo as far as the lightweight GIS in action is concerned. So I'll talk about now in the next couple of slides about how GIS is now closely linked with the way C4ISR operations are being fought. The GIS architecture initially, when it got started, it was all about a single machine, single computer. This we are talking of the 1980s. Subsequently, it moved to local area networks, multi-user, department, and enterprise-wide. Today we are talking of net-centric warfare. You have already seen how the OODA loop is getting shortened. And how GIS is now, we are talking of in a scalable global infrastructure or on a pan-India basis, where you have multi-sources of information, all data fused together, and so on. So GIS has, in all of these, GIS is there, and this is how it has been focused. GIS has not just got evolved just because the computational technology has got increased. GIS has also got improved because of the way the science has improved. The computation and the network is definitely there, but then the way the measurement science, the lasers and all which are now coming in, all the measurement science itself has improved. The data policies which are there, that has become more open, and because data is now more available, GIS is being used in every possible way in as far as defense forces is concerned. Geographic science, in terms of the various modeling, the relationships, the various algorithms which are there, those have also improved tremendously because of the various R&D which has been going on in this field. So the idea now is how we are opening up of the GIS to everyone. Earlier it was only focused to a few GIS-centric professionals, and now we are talking of GIS being available to even the smallest soldier. GIS is now, the focus is getting implemented in multiple patterns. So whether it is desktop, server, enterprise, that is definitely there. It could be an enterprise of mega enterprise. It could be even the cloud. WebGIS is definitely available, and for all types of devices. So information and intelligence is now being made available on demand across. If we move further, the framework itself is now changing. The idea is to provide a complete framework as far as GIS is concerned. So all the various functionalities which have been written down, right from discover, create, manage, and collaboration, is all possible using a GIS. And it is available on the web, it is available on mobile devices, it's available on desktops. And it's available from where is that information coming? The information is available either locally or through the enterprise or available all through the cloud. So I've given you a small background, giving you how the technology is moving as far as GIS is concerned. So what is the need for a lightweight GIS if you have so much of technology available? So for that, I'm showing a slide in which how we are evolving right from the sensor to the shooter. So the various tactical C3I programs that we have, right, like say a battlefield surveillance system where you have multiple sensors, it could be satellite imagery, UAVs, it could be radars, all those sensors are giving information to a geospatial server. And that server is then computing all this and giving information to the commander to take a decision on. That is where the CIDSS or the Combat Information Decision Support System comes in, giving intelligence also in the output. So this is one category of this entire tactical C3I programs. And you'll be able to appreciate a natural extension of this is where the BMS program or the battlefield management system fits in. So the data which is coming from the geospatial server is actually being used through a STATCOM link or through any of the communication links that we have through a radio, and being provided through either the mounted or the dismounted soldier. So ultimately it is the soldier, whether he is mounted or dismounted, he is the one who's gaining all that information. And where is that information is coming in? It's coming right from where it started, that is from the sensors. So this is what I want to show in this slide is that the BMS is actually a natural extension or a logical extension of the CIDSS or the battlefield surveillance system programs. Here I've shown the geospatial server as a single entity. It might be multiple, it could be two more or whatever, depending upon the hierarchy or the echelons in which we are working in our defense organization. So with this background, you can see, I'm trying to show you what is the sort of complexity which is involved as far as the lightweight GIS software is concerned. You require lightweight because ultimately the GIS software is going to go into a soldier's mobile device, a device or a hardware which has got a small form factor, obviously, and because of the small factor, it has limitations of CPU speed, it has limitation of RAM availability, and so on. Therefore, the full power of a GIS cannot be used in such a small factor. Moreover, when you have a small form factor, there are different types of operating systems which have also got evolved. You have Windows Mobile, you have Android, Linux, iOS, and so on. Each of these operating systems have been designed or developed basically catering for certain aspects of the hardware in mind and certain aspects of how the how the hardware is going to be ultimately used. It could be used in the form of a phone, it could be used for a GIS and so on. So keeping that in mind, that is the next important challenge that we have, or complexity which we have. The data itself will be in multiple types of formats. It need not be that it's only in one type of format. So keeping various types of format, creating libraries for each of them, then trying to interoperate, all that thing introduces a level of complexity as far as the lightweight GIS is concerned. Then you have the development, because a plain vanilla GIS would be of no use to a soldier. Ultimately, he requires an application which has to be developed on it. An application specifically so that the soldier can utilize it in a proper way. So applications, obviously, they require various development environments. And development environments also depend on the type of operating system which is there. So Java, .NET, Qt, and C++, various types of development environments have to be thought of. So when you are planning, or when we are having a GIS, you can think of various types of development environments which will exactly fit into your scheme of things. Different types of analysis features, integration with various types of devices, because the mobile device is going to interact with the GPS for its own location. It's going to interact with the camera probably to take pictures which are geotagged. It's going to interact with the radio to probably send information, and so on. Then it has got to integrate with the server, because ultimately it's going to consume various types of services, the web services, probably because that's from where the data is going to come from. And finally, it's going to be connected as well as in disconnected mode of operation is going to work. This introduces all these various factors, introduces large amount of complexities when we are talking in terms of a lightweight GIS. So what should a lightweight GIS actually have? What are some of the challenges which will be there? So it should have, obviously, it should be suitable for a small form factor, needless to say, and obviously it should have a small footprint. Another aspect is, as far as the installation is concerned, zero installation, no setup. Immediately you just use it from a pen drive and it should start working. You don't have to install it, take time to do all those things, and then it should start running. Soldiers at the battlefield will never have that sort of time. That luxury will never be available. So no setup. It should be available for, say, multiple OSs, for example. It should be suitable for both connected and disconnected mode of operation. If you're connected, you should be able to pick up data from the server and probably push data back into the server. But what about when you are disconnected? What happens in those cases? So those things have to be actually taken care of. And then it should be suitable for low bandwidth networks, the data which is actually flowing up and down. And finally, if you want proper applications to get developed, the programming or the development effort which is required, that should get reduced. And that can come in only when you have some sort of modern architecture, a different architecture for this sort of work. Since I found a lot of engineers from Bell, and also I found officers from DRDO, scientists from DRDO, I thought I'll take few slides to show you how the design of the lightweight GIS would actually take place. This is a typical design of a general GIS engine. So it has got a data access layer where it is picking up data from a local data store. The data store would have, say, the base map data as well as the operational dynamic data. It will have a data access layer which caters for all the libraries which will require for the various types of formats and the database access itself. Then it has its analytical engine. That's the power of the GIS is actually in the analysis. So spatial, 3D, network, various types of data processing, queries, all those things are actually taken care of by the analytical engine. And then you come to the drawing engine, because whatever you have analyzed has to then get displayed. It has to visualized. And that visualization happens through a projection system, because there's a projection system and datums involved. There's symbology, labeling, and so many other aspects which are into a GIS engine. So all these things actually make the GIS very, very heavy. So if I have to make this GIS lightweight, what am I going to do? What am I going to do is very simple, because I'm going to take parts of this particular modules or of this engine and shift it probably somewhere else. So where do I shift it? Very simply, I shift it on towards the server side. So much of the processing will actually be shifted to the server side, because the server has more processing or computational power, and the device has comparatively less. So the device has a lightweight GIS. So what do we do here? You can see the server side as well as the lightweight map engine. And this is where the server side has the enterprise data store. It has all the base maps, the static data, that is all available at the server side. Then the analytical engine is the place where the various web processing services are done. The processing is not done locally. The locally is only the analytical engine access layer, which actually sends information in to the barest extent that, okay, what sort of analysis you want to do. But the analysis per se is actually happening at the server side. So web processing services are available for that purpose. And then you have WMS, WCS, those sort of services from where you are actually pulling out data which is there in the enterprise data store and bringing it to the local lightweight map engine. This is how you actually start creating a lightweight GIS. But this can happen only in a connected mode, obviously, because it requires a connection with the server. This obviously in a typical military sort of an environment, we have to cater for a disconnected mode. And also, if it disconnects, what happens? So you require a data store, a local data store. And probably many times what will happen is that the local data store will be used for your operational data or your dynamic data, whereas your base map data is actually taken care of by or the static data is taken care of by the enterprise data store. Now what happens in case when you are in a disconnected mode? The situation now is slightly different, and this is where a local server is actually is enabled inside as part of the lightweight map GIS. So there are lightweight local servers which are available, which has this analytical engine and this web server. This becomes part of your lightweight GIS. And this is available when you are in a disconnected mode. So when you and the whole thing is so light that even if you want to work from a pen drive, you can actually start your GIS and start working it directly from a pen drive. So just imagine if a soldier is going for, say, an operation, you want to give him some data, you want to tell him, okay, this is the GIS of the place. All you have to do is probably copy the relevant things on a pen drive, and I'll show it to you as part of my demonstration as well. That you can take that, give it to him, and he is able to take it. There are other security problems that might come in case he loses the pen drive and so on. But those can be thought of in a slightly different manner. But this is the sort of power which is available with GIS today. So the various things, right from capture, store, display, all the various, you would say, big functionalities of GIS can actually be introduced as part of this lightweight map engine. Now I'll introduce you to the lightweight GIS from ESRI. ESRI, as you know, is the pioneers as far as geographical information systems is concerned. They are world leaders, and they have come out with a product which has been designed upfront. It is not, they have not taken some open source and put something here and there, removed something and, okay, created it. It was actually built upfront right from the bottom, and they have created what is called the ArcGIS runtime. The ArcGIS runtime, some of the important aspects is given over here: small footprint, memory footprint, no installation or setup which is required, suitable for various types of operating systems including Android, iOS, Linux and so on. It's suitable for both connected and disconnected mode of operation, suitable for low bandwidth networks, and minimizes programming effort because it uses a modern architecture. This is the slide which I had shown you earlier, in which I had shown you that ArcGIS has a complete platform. So this mobile part or this ArcGIS runtime fits into this scheme of things. So as part of the entire platform story which we have, you have ArcGIS runtime also fitting into this. The new architecture caters is a pure 64-bit, native 64-bit sort of an application. So the idea is to be able to use the complete hardware capability which is available as far as the system is concerned. So some of the other points: native 64-bit execution utilizes the hardware. The programming pattern is asynchronous, which is different from the usual way we program today, because that is how when the developers are developing an application, only those portions of the code which is actually required for running it, only those portions of the code or the classes or the functions, they are the ones which are actually deployed in or run in the RAM. A complete simplified sort of a deployment. You can have multiple such instances running on the same machine. It's not that you have set up one, so the next another one you cannot set it up. Multiple sort of instances can run. It's got code 2D mapping. The 3D mapping is also expected anytime as part of the next release. Python scripting, enterprise as well as file geodatabases, geoprocessing, all those features which are generally required is available. It has got various types of data format support. Editing is a possibility over here. And map display, the rendering, everything has been developed upfront, totally changed, completely different architecture. It supports military symbols. It supports developer created symbols as well. So these are some of the features which are available as part of the ArcGIS runtime. So it's part of the ArcGIS family, because of which interoperability will definitely not be an issue. So now I'd like to show you ArcGIS runtime in action. What I've got is a pen drive, and I'll first show you the GIS running from the pen drive itself. So okay, this is the pen drive which is there. I've got my data and everything. There is an exe file over here which I'm going to run. So I've created some vector layers, map of India, and as far as data related to Punjab, I'm going to put those. So I'm zooming in. As you zoom in, you'll keep getting more and more layers. So scale-based zooming in, panning, you can see how the panning takes place. It's quite smooth because it's using the full power which is available with the machine. Each of those layers which are there, you can switch on and switch off those layers. Like for example, if I want to switch off this river, so I can just switch that off. If you want, for example, I'll just hide the table of contents. I'll do an identify task, which is like, suppose I want to get some more information about the river. I've got, this is what we call as identify. These are standard GIS functions which are available. So this is identify. I can identify the river or a particular point. So those things are definitely there. Suppose I want to do say a geoprocessing task. For example, one of the simplest is say a buffer. So I want to create a buffer here. I'll do that. Oh, as luck would have. Okay, maybe I'll do something different. This is, I'm creating a point. I've created a point. I can create a line. I have not used specifically military symbols here. I can reduce the transparency so that the symbols become a little better. I can, sorry, I can put polygons and I can clear graphics. So simple things available directly of this thing. Not much of code has to be written for it. Very, very simplistic. It can be done. So this is running directly from the pen drive. No copying, no installation, nothing whatsoever. I'll close this. Now I'll show you something which I've got here. This is an Android device. And here what I wanted to show you is, so what I've done is I've used an emulator so that the Android devices, I can project it on the screen itself. There will be a little gap from what you see here and what is displayed because it takes some time. Okay. So I can pan it and zoom it. This is how I've zoomed it. Actually the resolution of this is a little lesser, so it's getting cut at the bottom. And I've put a small simulator inside so that I can show the movement of a vehicle. Now, in this mode of working, what is happening is that the vehicle remains on the center of the screen, and it is the map background which is actually moving. So the background map is actually moving and the vehicle remains on the center of the screen. I can actually rotate this map depending upon which direction I have to go. And you can see that this particular thing is also showing where the north is. Now this case what happens is that the map is fixed and the actual vehicle that is actually moving. There's a simulator which is giving the various values because of which that movement is being displayed. And now I've brought it down to the back to this earlier mode where you had the vehicle in the center and the map moving. You can even show the grid values and all that. It will come here. The grid, that aspect is available. And if you want to bring it back to the old one, that's there. Then in addition to that, this particular application, we call it as the squad leader. Suppose the squad leader is having it. He sees certain things on ground and he wants to report that matter to the rest of the various troops which are around. So if you want to do that, he's able to, it will take some. So here is the small spot report he can send. He can send, say, which team size, whether it's a squad, what is the sort of activity, for example, stationary. This can be customized to a particular requirement. And he can give some comments, he can give what type of irregular troops and so on. And then he can send this information. Once he sends, he can keep passing this information as part of his activity. He's patrolling on a route and he can keep giving that information. So this is a case where a small GIS platform, an Android device, a normal tablet, can be used very, very effectively, communicating with the rest of your troops as also showing your own position and so on. So with that, I have come to the end of my presentation. I will take questions at the end. Thank you. Thank you. Thank you for your patient hearing.
Thank you very much. Very interesting presentation.